In this video, I thought I would solve a problem that is a lot like a practice problem I've given you to do. So we have 1, 2, 3, 4, 5, 6 activities, and I've written the time for each activity inside the circles. And then we have the cost per day for crashing each activity, and then the number of days that each activity can be crashed. And benefit per day is $5,000. So anything that costs more than $5,000 a day to crash, obviously we don't want to do. So forget about F. I'm just going to cross it out there. Forget about D. Too expensive. I'm going to cross it out. So let's look at the paths through the network to see which one is critical. So there's the one across the top here, A to B to D to F. And then there's the one through the middle, A to B to E to F, and then the one along the bottom, A to C to E to F. Now this first one takes 7 plus 3 is 10, plus 3 plus 4 is 17 days. This one takes 10 plus 10, 20 days. This one takes 9 plus 10, 19 days, right? So the longest one is 20 days. So that's the one coming through there. If you want, you could notate it however you like, just so you can remember what's critical and what you should think about crashing. So we want to crash A or B or E, and we're going to try to figure out the cheapest one. So A is $4,200, B is 15, E is 12. All right, E is the cheapest. So crash E. We can crash it now 3 times. And anything with an E is 1 day faster. So the ABDF, no E on that one, so it stays at 17. ABEF, that one here, it has an E, so it's 1 day faster, down to 19. A to C to E to F, also 1 day faster, it's down to 18. So our critical path is unchanged. It's still ABEF, and the thing we crashed last time, E, is still crashable, so we'll crash it again. I guess if you want, you can mark along here. Now it's down to 4 days. We can crash it 2 more times if we want to. All right, so let's see here. When we crashed it, ABDF, no change, still 17 days. ABEF, down to 18. ACEF, down to 17. Well, that was really exciting, wasn't it? Critical path, still not changed. Okay, let's do this again. So we're going to crash E a 3rd time now. And ABDF, still no change, it's down to 17 days. ABEF down to 17 days. ACEF down to 16 days. And so this is the longest at 17, but we've got a tie. That one's also the longest. So if we want to speed things up, we've got to crash things obviously on both paths. So if we look at this picture here, if we crash E, we would have to crash, well, E by itself would speed this up to 16, but this would be stuck at 17. So we have to crash, well, if we crashed D, that's in parallel with E, but we've already decided that D is too expensive, so forget that. We can't crash F, so we've got to crash either A or B, and if we're doing that, then there's no need to crash E because A or B speeds up both of those paths. So A is 4,200, B is 15, so we're going to crash B for a cost of $1,500. And so this one has B on it, so it's down to 16 days. And this one has B on it, so it's down to 16 days. And this one does not have B on it, so it stays where it was, which was 16 days. And now everything is critical. Everything takes 16 days. B could be crashed twice originally, and now we can crash it 1 more time. Okay, so let's see what we got. We could crash B again if we wanted, and then that would take care of these 2 paths, but it wouldn't speed up the 3rd one. So in order to speed that one up, we'd have to crash something on here, and we've already had another thing we can do sometimes is we can cross out the things that are not crashable, like F is not crashable, profitably. So looking at the bottom one, you can crash A or C or E. And then on the top one, we can crash B and get both of those. So let's see if we crash B here and E there. So we crashed B and E. It seems a little funny, but what would happen? Okay, so this has got a B on it, so it would be down to 15 days. This has a B and an E on it, so it's going to be 2 days faster at 14, and then this has an E on it, so this is going to be down to 15 days. So now we've used up the last possibility on B, and I'm going to scribble that out, and we've used the last possible crashing on E, so scribble that out, and that. So we can't do any of that anymore. All we have left is A and C, and A is on the critical path, all 3 critical paths. I didn't quite give myself enough room here, did I? So we're going to crash A once, and these 2 that were the critical paths at 15 will now be down to 14. This will be down to 13. This will be down to 14, and then we can crash A one last time, and it'll be down to, sorry, those were critical paths. This one will be down to 12. This will be down to 13. So we've gone from 20 days down to 13 days. And let's see what the net profitability of these decisions is. So we crashed E 1, 2, 3, 4, 5 times. So crashing E, $1,200 times 5, $6,000. And we crashed B 1, 2 times. Don't ask me why I'm doing it in this order. Doesn't matter. So B was 1,500 times 2 is $3,000. So E and B, and then A crashed twice. 4,200 times 2 is 8,400. So if we add this all up, we got 400 there, and we have 6 plus 3 is 9, plus 18, so plus 8 is 17. So total expenses of 17,400. And again, we went from 20 days down to 13 days, an improvement of 7 days. So the net profit of the crashing is $5,000 per day saved, which was 7 days, minus 17,400. So we have 35,000 minus 17,400. So that gives us a net increase in profits of 17,600. And so to summarize, we crashed E 5 times, B 2 times, A 2 times, and ended up with a net benefit of 17,600.